Every time your inbox catches a spam email before you ever see it, there's a good chance a little algorithm rooted in 18th century probability is quietly doing the work. It's called naive Bayes, and it's one of the fastest, simplest classifiers we have anywhere in machine learning. It rests on a famous piece of probability theory, plus one assumption so bold and so obviously wrong that it's literally written into the name. And somehow, despite that assumption being false, it works remarkably well in practice. Let's see how it pulls that off. Let's walk through how it actually classifies something, say, deciding whether an email is spam. Everything starts from the prior. For each class, spam or not spam, you begin with how common the class is overall in your data. If most mail is legitimate, that baseline expectation leans that way before you've even read a single word of the message in front of you. Then you fold in the evidence. For every feature, each word in the email, you multiply in how likely that word is under each class. Here is the famous naive move. You pretend the words are independent of one another. So instead of wrestling with how they combine, you could just keep multiplying single probabilities together. Multiplying those probabilities together gives you a score for each class. It's the prior times the product of all the individual word likelihoods. A single number that says how well this particular class explains the email you're looking at right now. One score for spam, one for legitimate. Finally, you compare. Whichever class ends up with the highest score wins, and that becomes the prediction. Smoothing quietly patches any unseen word, so a lone zero can't wipe out an entire class. Now, why make that strange independence assumption in the first place? It comes down to a trade-off. Modeling every interaction between features is the accurate dream. Words really do depend on each other in real language, and capturing all of that jointly would be faithful to reality. But it's brutally data-hungry and slow, because the number of combinations explodes as features pile up, and you'd need an enormous amount of data to pin them all down. Naive Bayes makes the opposite bet. Pretend the features are independent given the class, and that hard joint estimation collapses into simply multiplying separate probabilities together. It's rarely literally true in the real world, yet it's blazing fast, needs very little training data, and still lands the right answer far more often than it has any right to. So here are the three ideas that make this classifier tick. First, the theorem is the engine. Bayes' rule lets you flip a conditional probability, turning how likely the features are given a class into how likely the class is given the features. That flip is the entire foundation. Second, the naive assumption. Treating every feature as conditionally independent given the class is what makes the math tractable. It's a shortcut that turns a hard problem into a quick chain of multiplications. Third, it punches well above its weight. Despite that unrealistic independence assumption, it stays a strong, cheap baseline, especially for text classification and spam detection, and it trains in a flash on very little data. That combination of speed and accuracy is why it has stuck around for decades. Let's pin down the essentials before we finish. Naive Bayes is a fast probabilistic classifier built on Bayes' theorem, famous for filtering spam. It makes one bold assumption that all features are conditionally independent given the class, which collapses hard estimation into simple multiplication. Prediction multiplies each class prior by the product of its feature likelihoods and picks the highest score, with smoothing quietly handling unseen features, so a single zero can't wipe out a class. Wrong in theory, strong in practice, it remains a superb cheap baseline for text. If breakdowns like this are your thing, Standarity.com is packed with them. Come explore.